I don't know, out of sequence, not out of sequence, but I went over polar coordinates first, and today I'm going to go over parametric. And I'm also going kind of slow. I know it's the end of the semester and I'm supposed to cover a whole unit in 2 days, but I'm not doing that. I'm covering it to where you can make the transition from the algebra polar coordinates to the calculus polar equations. And I'm going to do the same thing with the parametric. I'm going to go over the parametric as far as the algebra outlook and then go into the calculus probably Tuesday. Okay, I might get into it today with the parametrics. I don't know. It all depends on how fast we go. So let's go ahead and start talking about the parametrics. Let me get my calculus. Let me put my calculus notes over here because I don't want to go into those unless yeah. Now, for those of you that didn't know, I had a test this last Thursday, which was terrible. And I told you about that, I think, Tuesday, but it was terrible. But one of the things that we have to study as a surveyor, we don't ever use, but we have to study it, is the satellites on GPS. And one of the things we have to know is how to calculate the response of a receiver to a satellite. Like we're going to be able to fix the satellite, or we're going to be able to fix the receiver. But anyway, don't even get me started on that. I think it's a stupid thing to have, but anyway, be tested on. But anyway, I think it's okay to test the person that makes the receiver and makes the satellite. I think that's important, but I don't know why I have to. Anyway, through preaching. So, what's that got to do with this? Well, I'm going to just draw a picture of one of, the examples of what I'm talking about. Not that we're going to do the problem, but just to show you where parametric equations have applications. So you got a satellite here, you got a satellite here, you got a satellite here, and you got a satellite here. And there's the Earth, and you got a receiver right here. Okay? Now, the standard on a GPS survey and receiver is like 3 millimeters. Okay? If you do a regular receiver that you buy at Walmart, you're talking about 8 to 10 feet because it only uses one satellite. But a GPS uses 4. It has to use 4. If it doesn't have 4 satellites, 4 or more satellites, it will not work. The receiver won't read. Okay? Now, the reason you have to have 4 satellites is because there's 3 coordinates. We live in 3D space, right? So there's 3 coordinates, X, Y, and Z. But what's the 4th one?
Yes.
Close? No. That's a verb. A verb don't apply. This is a noun. Catch? Huh? Bitch.
Bitch.
Oh, I thought you said bitch. Yeah, you could bitch about it. Anybody got? Good job. The 4th dimension is what? T. So why do you have to have 4 satellites? 4 equations, 4 unknowns. 4 equations, 4 unknowns. So that's why, and that's the basis for the GPS system, is you got to have 4 satellites because you're solving for 4 what? Unknowns.
So when we use Google Maps, you're
Okay, I'm sorry. You're not supposed to ask a question here. I'm showing you something, all right? Yeah, this GPS is at 304 McClure Road, and it's on top of the hill. Okay, is that good? Any other questions? Detailed questions? You'll know what color it is?
Yeah, what color is it?
It's blue. Any others?
So we already knew NASA and everything. Already knew about the fourth dimension, and
They didn't tell anybody.
we travel through.
Yeah,
Everything.
that we can already travel. They just don't tell you about
So
it.
why they make the movie Interstellar?
I don't know. Anyway, the whole point is I'm trying to get you to think. Parametric equation throws this into the mix with these two. That's what a parametric equation does. All right.
So
Why not Z? Well, it will throw Z when you get to calculus 3, because you think in terms of a three-dimensional space.
does that happen when you use your, like even your GPS on your phone or anything?
Yeah, except it don't use all 4 satellites, it only uses 1 or 2. The more satellites you use, the more what? More precise, more accurate, whichever one it is. Okay? The more precise it is, more accurate.
How many satellites they got up there anyway?
24. Yep. Well, that's for GPS.
A lot more.
It was like 107.
We got 100.
Talk to Mr. Tinfoil. He knows all about it. He puts tinfoil on his head. Okay? Now, apply this to math that trains you for such things. And we have a non-function. Now, when you have a non-function or something that is out of the ordinary from what you're usually talking about, a function would be x squared. That's what you're used to dealing with. X squared. 1 over x. 1 over x minus 2. X squared plus 2x plus 4. You've been dealing with those up until now. Now you're dealing with one of these guys. This is called a conic. If you look in your notes, your, what do you call it thing? Syllabus. You're talking about conic sections. This is a conic. All right. There's a 3-dimensional representation in your book. You can look at it and go, ooh, ah, but this is a conic. All right. You draw a straight line through it. You get 2 points, which means it's not a what? Non-function. So if you come up to a non-function, you can either quit or you can solve it. Now you don't want to quit because then you'll get fired and live in a ditch. So you have to solve it. So you have to break it up into 2. All right, and you create 2 functions. Okay, create 2 functions, and we take our handy dandy highlighter. There's the function. And there's the function. Now let's start right here and let's say we're walking around this guy. So we walk here, we walk here, we walk here, 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 and we're going in this direction. So that's the initial point. We're walking. Now, if you think about walking on these curves, then you think about a parametric equation. Because at 0 seconds, you're at 4 and -4. At 0 seconds, you're at 4 and -4. At 1 second, you're at 3 and -3. And at 2, 3, 4, 5, 6 seconds, you're at 2 and 4. You see where the third element comes in. Okay, now what we're doing is we're making that transition from old algebra. Okay, there's a point right here on this line, duh. X and Y. And we're making the transition from that to following a particle in what? Space. In space and motion. And we're making that transition. Okay? We're graduating from Redneckville. We're moving on up into dang old physics. So that's what you're doing. You're throwing in time. Now, you can't just say, okay, we're just throwing time, take the derivative of everything and just say, okay, at 3 seconds we're here. No, you can't just do that. All right. This is just following the line. Now, you're going to have to break it up into two functions. One that describes X. And one that describes Y. Now, most of the time, I'm going to go ahead and tell you this. Most of the time, you're going to be given this information. The whole point of me telling you, non-function, create two functions, one describes X, one describes Y, is when you're given two functions, you'll know what they are. When they say X is equal to 1 plus T, Y is equal to 3 minus T. Then you know what? That's the two functions you're dealing with. I'm not going to sit here and tell you. Now, I'm going to show you how we come up with it. But I'm not going to, if I give you the test on your last test, which is going to start Tuesday, okay? And it's going to have like 10 questions on it online. One question is going to be create a function, create a parametric equation from this graph. No, it's not. Okay? The only thing I'm going to put on the test that starts Tuesday is finding the surface of a parametric surface, finding the area of a parametric equation, finding the area of a polar equation or a polar surface or whatever the case may be. Okay? But you got to understand what a polar surface is or a polar equation is, and you got to understand what a parametric equation is before you can even do that. So, most of the time this is going to be given. But I'm going to show you how to get, I'm going to finish this problem. This bottom part, or one section, is going to be Y is equal to 2t. And the other part is X is equal to 1/2 t squared. Now again, I'm giving you that information. You could derive it from the points. If you remember back in algebra, you could actually take 2 points on a curve and find the equation. We're not going to do all that. Okay? And it's from -4 to 4. And they give you that. Just come on whenever, that's fine. And I want you to draw a chart, just like you did back in pre-algebra, with X and Y. And just, I always use both sides of the negative. That's a fraction. So if you've had me in algebra, you know I use multiples as a denominator. So that's -4, -2, 0, 2, and 4. Now, find your X and find your Y. And then I want you to plot it. Sketch it. Now, all y'all can do that because that's nothing but algebra. So, if you can't do it, then you what at algebra? You suck, yeah. Okay, y'all gotta tell me what Yeti is. I have seen, over the last 3 days, I have seen 3 things that have Yeti on it. Now, 4 things. Your computer and your hat. What the hell is a Yeti?
They make coolers. Yeah, they make coolers and like.
Is that like a wine cooler or is it a?
No, like.
Okay, so now now the craze is wearing Yeti cooler on your clothes.
I mean, they make good stuff. It's really expensive though.
That's it, right there. Okay, now we're at it. Okay, now I understand it.
Just the tinfoil.
I understand it now. Yeah. And Playboy has really good articles.
Playboy has articles.
A while back, it was what he had to have right here, Mountain Face or something face.
North Face.
North Face.
Yeah.
Now it's Yeti.
I think North Face is still a thing though.
Oh, it is. It's still.
I think so.
Okay.
Yeah. I don't know.
Yeah, in elementary and middle school.
So 10 full blocks, you lose out on a lot. All right, plug and chug, and then I want you to graph it. And then after you graph it, I want you to put on each point what that point is in relation to time. All right, I'm going to change this. Well, I'll just highlight it. This is yellow. So I'm going to take yellow pen. Oh, God, I better not do that. Just forget it. I'll do that. Y'all's head explode. Let me do green. Let's see. I made him mad. See, he's leaving. Yeti. And use my handy dandy pen. Nope. You don't have negative time. Time is, well, yeah, you'll see in just a minute. All right, so Y is my green, okay? So what's negative 4 times 2? Negative 8. And negative 2 times 2? Negative 4. I have no mouse pad. There it is. Hold on a second. There, that's better. 0 times anything is what? 0. 2 is 4, and 4 is 8. Now I'm going to take my handy dandy blue pen and my handy dandy highlighter.
So you got negative 4 by multiplying negative 2 times negative 2.
Right here. 2 times negative 4.
Oh, so all you're doing is plugging all of these in back in.
Yeah, that's what you did back in pre-algebra. You remember pre-algebra? Okay. Now here's my X. I'm going to do it in blue. I have to use a light shade of blue because you won't be able to see the formula. And I can't use this shade of blue over here because y'all will bitch about that. So I'm going to have to use 2 different shades of blue.
Because that would just bother me.
Anyway, did y'all hear anything? Negative 4 squared is what? Yeah, last time I checked it was 16. 16 divided by 2 is? Negative 2 squared is 4. 4 divided by 2 is? I'll do this one for you. 2 is 2 squared is 2, and 4 is 8. Now, when you plot these guys, what are you going to get? Huh?
That thing you used earlier.
That thing we had, hyperbola. Yeah. So we're going to take our handy dandy 8 and negative 8. So 8, negative 8, 2, negative 4, 0, 0, 2 and 4, 8 and 8. So you get the parabola, but what you need to realize is, take our handy dandy straight edge, and let's use magenta. You suck. All right, that's 0. And what is this? 2. And what is this? 4. Take my handy dandy pen. And this is t is equal to what? 0. T is equal to what? 2. And t is equal to what? 4. Now, the reason it's different is because you got 2 formulas. That's why you come up with the negatives. Okay? Or you plug in the negatives because it represents the 4 and the 2. I'm sorry. All right? But what you're realizing is at 2 seconds, you're going to be here. And at 4 seconds, you're going to be here. Now, if you go this way, at 0, you're going to be here. At 2 seconds, you're going to be here. And at 4 seconds, you're going to be here. Now, I don't want you to think too much on this. What I want you to see is now at the points when you're talking about parametric equations, you can't just say x and y. You have to say at t is equal to 0, x is this and y is this. You got to start thinking like that when you're talking about parametric equations. Capiche? All right, now let's change a parametric to a normal equation. And I'll show you how to do that. Y is equal to 2t. And this is a way a parametric is going to be given to you. It's going to be given to you in terms of x and y. And okay, this is just y is equal to 2t. And I think the other one, oh, this is one we just, I stapled the wrong page. What's the other one? Y is equal to 2t and x is equal to 1/2 t squared. X is equal to 1/2 t squared. Now, does anybody remember solving systems of equations in algebra? And this is a little bit of what I was talking about with the satellites and finding t, or using t to find x, y, and z. This is what they're doing. Solving systems of what? Equations. So see what you can do with that. I want you to use substitution. I want you to plug something in the other. Huh? What? Let me just say this. Solve the one on the left because it's easy. Solve it for t.
I was just going to solve it for T. I didn't know what we were doing.
No, solve the one on the left for t.
Okay.
And then do something with that. You've got to get it in terms of a normal equation, which means x and what? There ain't going to be no t. In other words, parametric means you have t involved. Normal means that t is what? Not involved. So t is equal to what? And what did you do back in solving systems of equations when you wanted to solve for another variable? It's called substitution method. Plug it in. So what am I going to plug in? Y divided by 2 in for what? Good. X is equal to 1/2 parentheses squared. And that means we're going to plug in y over 2. And be careful. X is equal to y squared over 8. Right? X is equal to y squared over 8. Check me, make sure. Now, we're used to solving for what? Y. So, solve for y. 8x is equal to y squared. Y is equal to what? Square root of 8x. And now what could I do with this? I could plug it back in and get another equation up here if you wanted to. But my right out to the side, no t's. Okay. Parametric has t involved. Normal, or what you're used to in algebra, the algebraic, which means x and y, has no t's. So let's, some of y'all going, hey, I understand this. Good, let me blow you out of the water. Ready? X is equal to 7 cosine. I don't know how to do it. I quit. Y is equal to 10 sine of theta. Yeah, it's parametric because it has theta in it, and theta is polar coordinate. So that's why I show polar coordinate first, because in a minute you're going to see where the polar coordinates tie in with the parametric. That's why I show polar coordinates first. So solve it. You're going to have to use identity, Pythagorean. Use the Pythagorean identity. It'll help you out. This is problem solving, right? Cosine squared, sine squared plus cosine squared is equal to 1, right below that. And then try to figure out how you can use cosine and sine. I just gave you a hint. And to answer your question, how do you know this is a parametric equation? You're given two equations in terms of what? X and y. If it was a normal equation, it would be y is equal to 4x plus 2. Or y is equal to whatever. So can anybody give me a hint what to do?
Solve for cosine.
Good job. You took the hint. Solve for cosine and sine. Cosine of theta is equal to x over what? 7. And sine of theta is equal to y over 10. Now finish it using the Pythagorean identity. Cosine squared or sine squared theta plus cosine squared theta is equal to 1. So what you gonna do? Remember, you want everything in terms of x and y in your final equation because that's the normal. So square what? Yeah, but that'll still give us sine and cosine. We don't want that. Substitute in what? X over 7. Oh, I'm sorry. Y over 10 squared plus x over 7 squared equals 1. And what is that? Huh?
It's just a regular function.
It's a regular function, but what is it? What does it look like? Close, not a circle. Ellipse. Good. So write that down. So, not a function, normal equation, and ellipse, which is the shape of the earth.
Is the Earth getting bigger or smaller?
We're all going to die. Actually, it's stretching. Going this way because it's spinning. It's going this way. And we're all going to die. Huh? Actually, you can tie calc into philosophy all the time. We're all going to die. X squared over 16 plus, y squared over 1 is equal to 1. So now we're going from normal to parametric. Okay, erase the 1. And the only thing you got to remember on these is when you're dealing with, you just got to say x is equal to t. Go back to the walking the line. At 0, you got 0. At 2, you got 2. At 4, you got 4. So x is equal to what? T. Plug and chug. So t squared over 16 plus y squared equals 1. Finish that one. Well, how do you know what to solve for? Well, if you're going from a normal equation to a parametric equation, you've got to go from one equation to what? 2 equations, which is in terms of x and what? Well, in this one, we've got y, so we're going to solve for what? Y. So that gives us y squared is equal to 1 minus t squared over 16, and then that would be the what? Square root. So there's your parametric equation for y. Now find x. So with x, y is going to equal t. And you plug in t right here. And when you plug in t for y, you get x is equal to, I'll just go ahead and give you the answer, 4 times the square root of 1 minus t squared.
So how do we know that x is t?
Well, it's given. It's going to be given.
Is that gonna always be true?
Yeah, they're going to give you something. They're not just going to say x squared over 16 plus y squared over 1 and say solve for the parametric equation. They're going to give you something.
Would it also be given that y is equal to t?
Mm-hmm. Or something in the sentence or the directions will specify. I'm not going to ask you for those. I'm just trying to get you to see the difference between a normal equation and a parametric equation. That's what I'm trying to get you to see. Yes, sir. No. What?
I got a message from Mr. Blankenship. He'd like me to ask him if he can take the exam next week instead of working on.
I guess. He can take it online. I'm not worried about him taking it in class. If he's going to be gone, I'm not going to try to make him do that. Okay, now that I'm totally off my track now, thank you very much. I can't draw a circle. Yeah, I can. There's your circle. I think I might want to make it a little bit bigger. Okay, let's go into left field now.
We didn't get a good enough conversation before we started.
Well, y'all just sat there like a, I ain't gonna say what you sat there like, but anyway, like a bump on a log. You didn't say nothing, so I just started with math. You know that whatever you say right now, you're gonna be living with Mr. Schaller next, okay? Because he's a racist. Anything you say from now on, you already said it. You said Harriet Tubman.
I didn't say.
So he called you a racist. So you've got two roommates here, Mr. Schaller and Mr. Rochester are gonna lock their doors and they're gonna keep everybody out. I don't understand why they had to change the $20 bill. Why don't they just make another bill?
They should change
It's
it
a
to
distraction,
$10.
No, you know what I think it is? Pandering is what I think it is. It means snuggling up to your panda bear. Get one laugh. Have a female, one or two females. Okay, look it up. Somebody look it up. Pandering. Nope.
Is to gratify or indulge with an immoral or distasteful desire, need, or habit.
Yep.
That doesn't make sense.
Okay, look up. Type in Google. Really? Google pandering and then politics.
Oh, according to Wikipedia, this makes more sense. Pandering is the act of expressing one's views in accordance with the likes of a group to which is attempting to appeal.
There you go.
It's like just going against the crowd.
No, it's going
No, it's gonna move around.
Oh,
so that the crowd like it.
oh, okay.
So you figure it out. Why right now, we getting Harriet Tubman on a $20 bill?
The black people movement.
The black people movement.
What's that one called? The Black Lives Matter.
Black Lives Matter. I don't know. I think it has something to do with the Democrats pandering to the black vote.
They should change the $10 bill instead of the $20 bill.
Actually, they should just make a $25 bill and just put it on that. but somebody will be offended because they put her on an odd number. I mean, honestly, there is no way you can go in this country without some minority, and I hate to say that.
Yeah.
I'm offended.
Preach on. Tell 'em, boy.
No, I'm not preaching. We have turned into a nation of pansies. That's what we have turned into. We have no respect, none worldwide. I mean, Russia flies by our ships, and Iran, they do whatever they want to do. And the North Korean guy, the goofy guy, he does what he wants to do. No respect for the U.S. at all, because we have turned into a bunch of pansies. I'm offended.
You know what I told him?
I'm offended.
I said, we ought to make South Korea an island. We ought to blow that place up.
No, South Korea is our friend. It's North Korea. Okay, let's just blow up everybody. Okay, we're offended. I'm offended now because you said Harriet Tubman. Why Harriet Tubman? I'm offended. Oops, that doesn't work. Okay, I'm gonna make my.
Why are you drawing guns on
Did y'all hear about that?
Yeah, I'm drawing guns. No, I'm drawing radar. Of course, that's R, and I'm going to say R is equal to 5.
What do you think about that Clemson sit-in?
I have no idea what you're talking about. I have no idea what you're talking about. Let me guess. They are protesting because somebody's offended because of something. They saw a chalk writing of.
It was worse. It wasn't even that.
No, they were hanging bananas from side of the African American flag on campus. They were hanging bananas.
I'm not going to say a word. At 5, 0. T is equal to 0. At 0, -5. I want you to plot these points. T is equal to 2. Are y'all plotting these or are you talking? Because when I say plot, Mr. Rochester, that means you need to stop talking and plot. 5, 0, Mr. Rochester. That's the second time I've called your name. T is equal to 8. Plot those points.
But
No, 5, 0 is not the same.
as 5, 0 it is.
Is it
Yeah.
angled in radius or radius?
Think of walking. What?
Is the polar coordinates angled in radius?
We're not worried about. This is okay. We're not worried about this. These are just points.
Okay.
5, 0 is right here. So I'm gonna color 5, 0. I'm gonna color this one blue, and I'm gonna put it right here. 0, -5. What? Is right here. And 5 and 0 is where? So remember, we're thinking about walking around. You got it? You're walking around. So at t is equal to 0 seconds, we're right here. Boom. At 2 seconds, we're right here. So you could actually say this is probably what right here? 4 seconds. Then back here, and then back here. You see? We're going around the circle. You're walking around the circle. you are starting to think, those of you that are shaking your head and say, oh yeah, I see it. You're starting to see the connection between time and X and Y. Okay? So now let me floor you. This, of course, brings up this guy. And we all know that this is polar coordinates. So we could easily go over here and say X is equal to R cosine theta, and Y is equal to R sine theta. Okay, now I'm going to throw a little bit of a ratio in here, oral ratio. This is 360, and we all know that time is equal to 8 seconds. 1 revolution is equal to what? Time. So we can say 360 over 8t is equal to 45 degrees over 1. Okay, because I put this at about a 45-degree angle right here. That's what this point right here. Let me put that a different color. Let's make that red. And we'll put this right here. Now, if I wanted to find, per se, this point right here, if I wanted to go, and we'll color it blue, and I wanted to find this guy, then what I would do is I would say X is equal to 5 cosine, and then I would make that negative times negative 45t, because I'm making my X and Y coordinates in relation to time because of this right here. And Y is equal to 5 sine of negative 45t. Now, the whole purpose of me showing you this is not that I'm going to ask you a problem like this, but the only thing I want you to realize is the negative revolution of your angle right here.
Was 45 given?
Negative 45, yeah, I did that, yeah. Negative 45 degrees right here. And this is 45. Okay, you had to throw in t somehow, and the way you throw in t is right here, based on what's given. All right, and that introduces t in relation to theta, and then once t is in relation to theta, you can plug in for theta 45t or whatever the case may be. You've got to have a t in a parametric. So again, this is not what I'm leading up to. Is when you see a parametric equation, you're not going to go, what's that? It's kind of like implicit differentiation. I had to go through and show you in Calc 1, I had to show you what we were actually doing. That's what I'm doing right here. Same thing with polar. Now, when do we use parametric? Well, I'm going to give you a good example here. And it's not a test question, but you've got a crossbow. If you don't know what a crossbow is, it's your parents' fault. And it releases an arrow at 200 feet per second at an angle of 45 degrees. So, what goes up must come down. Projectile motion. T is equal to 0. T is equal to 1. T is equal to 2. And so on. They want to know how far does the arrow travel before it what? Hits the ground. Y is equal to 0. X, and this is given, X is equal to initial velocity cosine theta times t. And notice, you're talking about something in motion, just like we did on the circle. You're going to have the angle alpha times what? T. You're going to have some form of t in the angle because of that relationship. One revolution equals so much time. What was it? 1/4 was 2 seconds. Another one was 2 seconds. And another one was 2 seconds, and back to 8. So that time has relationships to the revolution. Kind of like when we did the relationship between polar coordinates. Y'all remember we did the revolutions? That same thing. Just one is parametric, one is polar. And then y is going to be almost the same, but it's got to have the gravity in it. So, dang old wind resistance, dang old gravity, dang old drag. Sine theta t minus 1/2 gt squared. Now, of course, you can't read that because it's on the right side, so I'll say it again. V sub O sine of theta times t minus 1/2 gt squared. Now, fill in what you can, then we'll go from there.
Wait, is that given?
Yeah, all that's given.
That y, okay.
Y is equal to V sub O, the initial velocity, sine of theta times t minus 1/2 of gt squared. Now, what does that FPS mean? Feet per second. So we're dealing in feet. So what's the gravity? What's the acceleration due to gravity of feet? How much? No, you're switching to meters. Don't confuse the class now, Mr. Swanson.
9.8 meters.
Okay. How many?
9.8 meters.
Not 9.8. 32. Now y'all's head's supposed to explode like we did the first week of class. Remember? What's that for? It's 32 for government work. Close enough for government work. 32 is good. So G is 32. And then hopefully we'll write on the left side of the board and we'll be able to figure out what we're writing.
So we would go for like each second, like we would figure out.
No, we're going to find what do we want to find? How far does the arrow travel before it sticks in the ground? At y is equal to 0. Hint, hint. Y is equal to 0. Hint, hint. Huh? Most of this is plug and chug. So I want you to give me 2 equations down here. And what's the variable is going to be unknown? Probably t. Because it's a parametric. I don't know how much exposure do we have. I don't know if we even talk about parametrics in first calc, do we?
No.
Okay. Huh?
I think we did watching for a little bit, but not much.
Well, that's why I start from the beginning, because I don't remember talking about it in Calc 1. So, x is equal to 200 cosine 45, 45, and I'm going to write that in parentheses, t. The reason I write it in parentheses is what is r cosine theta? R cosine theta is what? X. So that's why I want to kind of put that in parentheses. Y is equal to 200 sine 45 times t minus 1/2 32 times what? T. Clean that up a little bit. Right here, clean that up. 32. What does that come out to be? 16t squared. And what do you start to see? Well, no. What do you see here when you see 16t squared? What do you think of when you see that?
Blue square.
Quadratic.
That, yeah, that's right.
So you start to see, and you can go ahead and punch that in the calculator. You start to see a quadratic. Now let's see. If we got a quadratic. Let's go back to algebra. What is these 2 points called? X what? X-intercept. We won't find the x-intercept. We plug in 0 for it.
T. Wow.
Thank you.
I don't know what I'm thinking. I'm really confused actually.
How are you confused?
I don't understand what we're doing. Like,
Okay, if you take a crossbow and you shot it up in the air and you release it, what is that? Tell me what the arrow is going to do.
I mean, I know
It's going to go like this, and then it's going to stick in the ground.
I believe.
You're supposed to go. You're supposed to go. Oh, how do you do it? You do your little. Ooh, I'm gonna. All right. What's your question?
With the x's and y equations, what are we doing with that? Like, what's?
Okay. Think of your solving systems of equations. 2x plus 3y is equal to 4. 4x minus 2y is equal to 2. What did we do back in Algebra 2? You solve for one, and then you plug and chug into the other, right?
Yeah.
Well, that's kind of what you've got here.
So we're plugging that into one.
No, we're not worried about x right now. We're trying to find where y is equal to what? So what are you going to do with that 0 up there? You're going to plug it in for y. And you've got a quadratic equal to what? 0. Factor. Basic factor.
Okay, so when we plug in 0 and you get all that mumbo.
Then you're going to get t is equal to what? A number.
Oh, so
and then
we
you're
solve
gonna-
for t then.
then you're gonna
okay,
plug-
well, I didn't know that. You could have just said that.
No. I'm not going to tell you that because look. If you plug in y is equal to 0, what's the only variable left? Then why should I tell you to solve for t? You should know that.
Because I didn't understand
You should
what
know
we
that.
were doing.
You should know that.
Okay, sorry about that. Continue, please, sir.
Well, look here. You agree that we want when y is equal to 0, do you agree that that's when the arrow hits the ground?
Yes.
All right. Then that means that we're looking for that, which I told you is, I gave you these t is equal to. So that green area represents the time that it takes for this arrow to hit the what? Hit the ground. Okay, so that's what we're, right there, t. So now we're solving for t.
Okay.
Do you understand?
Yes.
Ooh, I'm gonna. How you say it? I'm gonna leave. Is that what you said a while ago?
That was one of the main things she
Just did great, not agree.
No, this stupid pen picked the wrong thing. Ooh, I'm gonna leave. Now, basically, what you're dealing with, Miss Anthony, is right here. You're going, I don't know what to do. Well, at this point, what you need to do is clean up everything. Right here is the one you're targeting. You're targeting this one because of this guy right here. Okay? But you can't tell anything because you're looking at a bunch of crap. All right? You're looking at a bunch of junk. So the first thing I tell you to do is clean it up. And that's why I put the 16 there instead of the whatever over whatever. Start cleaning it up. Punch this in your calculator. I came up with 141.4. Y'all check me.
Yep.
So now I'm going to take 0 and plug it in. And I get 141.4 t minus 16t squared. Now, what does that look like? Negative 16t squared plus 141.4t is equal to 0. Well, what does that look like?
A standard form.
It looks like your Algebra 2 problems.
I need to erase it though. You thought erase it.
So now you've gone from a parametric equation down to something that you can what? Solve. So take out the t, and that's going to leave you with negative 16t plus 141.4 is equal to 0. So t is equal to 0, or t is equal to, well, 16, sorry, negative 16t plus 141.4 is equal to 0. Solve that. 16t plus 141.4, I got t is equal to 8.8 seconds. What'd y'all get? Now, Miss Anthony, now that we found t, what are you going to do? You have any idea?
Plug it into X.
Why? Because you're trying to find how many feet,
Right.
which is x. So you take the t, and you don't plug it in for x, you plug it in for t. Now, a lot of you saying, well, golly, that's easy. No, you're thinking not with 2 variables, you're thinking with what? 3. So you've got to know what you're looking for. You're not looking for t is equal to 1, t is equal to, you're not looking for that now. You've got t. T is standing over here beside your graph. It's standing over here and, it's counting, but it doesn't really have anything to do with the picture of your graph. It's just over here counting. Now you have to say, okay, at 8 seconds, at 8.8 seconds, what is my x coordinate? And when you plug all that in, you get x. I got 1244.5.
We need to laugh some because they're having too much fun.
Well, y'all can't have fun because y'all go complain to my department head and then I get in trouble. So how far did the arrow travel? 1,245 feet. This is a good problem, not for a test, It's a good problem for you to go over 2 or 3 times at home and see what you're actually doing. Kind of think of it like a runner on a track. You with me? Some of y'all ran track, all right? You going in an X and a Y direction, are you not? Hold on.
You said X equals what, 1,244 feet?
1245, yeah, rounded up. All right, here's your track. So I'm trying to give you another, and your runner is starting right here. Now, this coordinate system, this track, if you was to lay a coordinate system on it, it would intersect, really, hold on a minute. It would intersect where? Where he what? Where he starts. Now, he's going here. That's an X and Y coordinate. That's an X and Y coordinate. But who you got sitting over here? You got somebody over there with a what? With a stopwatch, right? Or you got somebody running the board over here, running the scoreboard with a stopwatch. What does that introduce into this coordinate system? It introduces a third what? Variable. But it's not in a XY coordinate system because the XY coordinate system is 3D, X, Y, and Z. So we can't turn T into Z. So what we do is we just have it sitting over to the side with a stopwatch. Think of it like that. Okay? And that time has a lot to do with you figuring out X and what? Y. So at this point, let's say this is 1 second. He's at whatever, 3, 4 or 3, 1 on the coordinate system. But that's at 1 second. At 2 seconds, he's here at X and Y. At 3 seconds, he's here. 4, 5, 6, 7, 8, 9, 10, 11. Now at 11 seconds, or 12 seconds, he basically what? Ran around that track. And you can tell distance-wise, Y and X, where he's at by the time. And that is parametric equations. All right? Now, the 2 things I'm going to leave you with, let's see what time it is. I got 15 minutes, and this would be perfect. The 2 things I'm going to leave you with, I'm not going to do polar. We're going to wait and do that Monday, okay, or Tuesday. When you're talking about parametric equations, you're talking about the area under a curve. And it is and this is going to be alpha and beta. Now alpha and beta is in terms of time. Alpha and beta are in terms of time.
So when you go minutes and seconds or not?
Well, it depends on the problem. Seconds most of the time. Now, what I like to tell students is, don't look at alpha and beta is x. Think of alpha and beta over here. Alpha and beta, meaning the time that you start and the time that you what? Finish. So you can put a little, looks like a stopwatch. Put it over here because y'all are thinking, when y'all see this problem, what do you call this? You call this alpha, and you call, A, and you call this what? B, because you're in, like, think of it like that, and that your time is over there on the side with the stopwatch, because that's all it is. Or you could put it right here. This is your start at the starting line, and this is your finish line. That's going to be the time he's working that top watch here. Don't think of it as a dimension. Think of it as just keeping time. X is equal to a function of time, as we discussed, and Y is equal to a function of time, as we discussed. Just like that first problem. Now, if you want to find that area, then you use, like I say, plug and chug.
So we go a lot farther than this in top 3.
We're making that transition. So here is the function. Here it is. I'm starting to get irritated. The antiderivative from your start time to your end time, from the starting line to the finish line, of g of t times f prime of t. Again, we're starting to see plug and what? Plug and chug. You take the derivative or the antiderivative, you take it and you plug it into an equation. And then you take the derivative or the antiderivative. Calc 3.
Does it matter if you put the A on top instead of the B, or?
Yeah, you read from left to right. So this is your finish line. This is going to be subtracting this guy. Okay? Just stay consistent. So I'm going to give you one. Write that down. This is your equation. This is what you need to remember. I haven't given you any equations. I gave you area and surface area. So far, your test that starts Tuesday will be on area, surface area, polar coordinate integration, and parametric. Well, here's parametric right here. Okay? And that's a T. We'll do polar Monday or Tuesday. So I'm going to give you a problem. What'd you say? Find the area enclosed by y is equal to 2.5 and x is equal to t minus 1 over t. Really? And y is equal to t plus 1 over t. T minus 1 over t and t plus 1 over t. Now you can actually graph on your graphing calculator. You can graph parametric as well as polar. So if you wanted to graph this, you would take your handy dandy graphing calculator. I think the TI-83 will do it. And go to mode and you'll see you can switch from parametric to polar. Parametric, make sure you do degrees. I think that's all you have to do. And then go to y is equal, and there's your x and y. So let's graph. X is equal to t. I think we hit variable. No. I don't know. I don't deal with the calculator very much, but let's see. I think you hit t. I don't know if we got a t on here. Let's see.
I think it's just on the S.
There it is. T minus 1 over t. Thank you. And then t plus 1 over t. T plus parentheses 1 over t. And then y is equal to 2.5. I don't know. Let's see if 2.5 will work. And graph. And 2.5 should be in there somewhere. Didn't graph it. Let me go zoom. Standard 6. Okay, well, it just stops. I got a sketch of it, so don't worry about that. You can graph it, you just have to go through and blow it up. I don't know. You might have to set the window. I don't know from that's T max 360. I think you probably can break that down to, I don't know, 10. Yeah. No, X max. I'm sorry, that's 360. That's your theta. Sorry. And we could go from -5 to +5. And the Y min, most of it's going to be in the first quadrant. So I'm going to go -1. Whatever. -1. Don't hit the arrow keys, Hubert. Why is it not taking it?
I think the calculator's trying to send me a message.
-1 to 10 or 5. Let's go to 5 and hit graph. Well, I messed it up. But anyway, you get some kind of graph. I don't use the calculator that much anyway. And we go through and we punch in, plug in 2.5 is equal to t. .5 is equal to t, because you want to see where it intersects. In other words, you know how to do this. And that comes out to be 2 and 1.5. Two and 1/2, sorry. So at 2 and 1/2, you're crossing 2.5. So 2.5 is right here. There's your line. Of course, I can't draw a dashed line on this stupid machine, but there's your dashed line. The graph looks something like this. Like that. And you're intersecting at t is equal to 1/2 and t is equal to 2 seconds. Whatever the units are. So now you want to go through, and that'll be your 1/2 and 2. That's your alpha, that's your beta. And you've got your y and your x. So you're going to basically set it up, to make a long story short. antiderivative from 1/2 to 2 of 2.5, because that's this curve right here, minus this curve, which is t plus 1 over t times 1 plus 1 over t squared dt. That's it. And that 1 plus 1 over t squared, what is that? The derivative of your first equation right here. Derivative of f of x. So I just wanted to focus on this because I wanted you to see most of this stuff right here is going to be given to you, okay? Most of it's going to be given. You might have to set this equal to this to find your t's. And we did that back area under a curve. When we wanted to find where they intersect, what do? Set them equal to what? Each other. Well, in this case, to find your t's, set where it's crossing to your y's, because that's where there's your y right there. So that's why you use this one right here. Okay? Now, write this on another page, on the next page. And that's going to integration from 1/2 to 2. And right now you're probably thinking, there's no way I can do this. Yeah, there is. I'm going to give you one step before because some of y'all are like combusting. I don't know why you're packing up right now, because I'm not through. Well, I don't care what time it is. 1 plus, you want to do this on the test, you want to make a f on it, and make a f on it. dt. And I'm going to distribute this negative 1/2, 2, and that's 2 minus t minus 1 over t becomes what? T to the negative 1. Put that in parentheses. And then this is 1 plus what? T to the negative 2. And then what do you do here? Algebra. What? What do you call this? Distribute, FOIL, distribute. Distributive law. And then what do you do after distributive law? Combine like what? Terms, and then take the integral of each one, because you got negatives and subtraction and addition. You break it up into separate intervals. Parametric, polar is about the same. Okay? Same thing. You're given an equation, you take the derivative, antiderivative, same type scenario, so you don't have t. Okay? So now what we've done Tuesday and today is go over an intro and an intro. And Tuesday I'm going to do nothing but how to find the area of both. Oh, shut this off.